Okay, if I'm please start. For today, we will have two presentations. The first is looking to the concurrency program analysis. So without that, now apart from the sequential programs, a lot of the program focusing if we're writing a wall, if we're using editing our text in the wall, if we are using Zoom to have a conference, and a lot of the programs are all concurrent programs. So in concurrent programs where we have a problem of determinism. That means each time we run a program and the result may be different. And so we are the concurrent programs where it's using some specific technique like lock, synchronization, Unsupervised to synchronize the program. And this topic is going to, this paper is going to analyzing when we are executing the concurrent programs, how do we identify the synchronization operations in the program? So there is a little bit theoretic, and I hope that you can pay a little bit attention to see what is research apart from AI research. And now a lot of you are looking to the AI research, and also hope that you can spend some time to understand what is the research on programming languages and software engineering. And the second topic, or the second presentation we're giving by Xianglin. And this is a very pure AI-driven technique. And it will be talk about how human will be taken into a loop to improve the reinforcement learning technique. Okay, Yuchen, please start.
Okay. Right, so this paper is on this tool called SherLock, which is an unsupervised synchronization-operation inference tool, right? So it's by these few people. Two of them are from principal researchers in Microsoft, and then another two are from the University of Chicago. And I can't really find this person's image, but so these are all the 5 people who worked on this tool. And the basic motivation is that, well, they want to identify synchronizations because it allows the programs to enforce a happens before relationship. So with these like linearizable histories, right, then we can use that to reason and analyze programs. So the current climate is that most of the tools that analyze concurrent programs rely on understanding semantics.
By the way, so is that possible that you introduce some basic concepts like happens before relationship?
Okay, so happens before relationship is just in a series of like parallel executions, you have events, and then some event X happens before event Y if it, yeah, so how do I explain? So it's like just, it happens before. So in a like parallel executions, right? If something happens here and something happens here, then you don't exactly know which one came first. And that's where like you need some sort of synchronizing between these two threads to happen. Right, so this may be in the form of like logical clocks or something. So let's say that you have a send event and then you have a receive event. So you will know that this receive event must happen after the send event due to all this like synchronization primitives. Yeah, so okay. Some properties of about that happened before is that it's transitive and that it's irreflexive. So some like an event cannot happen before itself. Yeah, so that's the.
Okay. So it's, I think you try to make a fairly clear explanations, but anyone have the problem to understand this part? So what is it happens before relation? Okay. Okay, I assume everyone is fine with the explanation. So maybe I just add a few complementary explanations. So when the programs are executing parallel, so I know a lot of you are writing programs in a sequential way. That means that when we write the statement, statement A must be executed after statement B and etc. But in the parallel and distributed programs, for AI, it will also have an application called federal learning. Federal learning, that means the data is stored in many nodes, in many servers, and we need to train the data stored in many different nodes simultaneously. So that means we will not train batch by batch. That means we train multiple batch all together. So that is in the setting of AI. But the parallel and the distributed programs that go far beyond that. So when we are having the Zoom meetings and we can see the videos, we can talk, and all the program, all these processes are working in a parallel and concurrently. So when we are writing concurrent and distributed systems, programs, and it is quite possible that these two processes are actuated simultaneously. However, if we want those processes to interact with each other, we have to make sure, sometimes we have to make sure one event has to be executed before the other, so that will make the logic correct. And the synchronization is a way to make sure such a happens before relation. Okay, keep going on.
Okay. Yes. So a lot of tools rely on understanding the semantics of these synchronizations, and the problem comes in because the semantics come from manual specification. So low-level primitives like atomic operations do not always enforce this happen before relationship. And on the other side, if you use like the threading and locking APIs, it's too complex and too semantic rich. So it's also very tedious and difficult to annotate. So this is why SherLock comes in. We have a tool to identify the synchronizations without understanding the semantics of the underlying framework, library, or operating system. And it is also able to do so unsupervised. Yeah, so they do this by framing the inference problem as a probabilistic inference problem.
Yeah, and it's better. And do you have any examples later? And maybe it's needed for a student to understand.
Not really. I think I have some diagrams, but
okay, sure. Please go on.
Yeah. So if anyone needs more elaboration, feel free to stop me. Okay, so the high-level idea is that these are some assumptions that they made in the paper, which they use to identify where the synchronizations happen. And the main bulk of the paper, I guess, is like the set of properties and hypotheses that they use to model how synchronizations work in the code base. And so they come up with a function to a system of like, it's kind of a linear programming. So they solve this linear programming problem, and then from there they are able to pinpoint which synchronizations are where. Yeah, and then they also have an extra mechanism to perturb the execution at some specific locations. So we'll see that later. Okay, so this is basically how it works, right? We have the program and the inputs, and then the observer instruments the program, and then it's able to determine some set of windows where synchronizations can happen. And then it's passed into the solver, which assigns a probability to all these events to determine which one is a synchronization. And then we have a perturber that injects a delay before the release of a lock. So that would either strongly support or like unsupport the current like guess given by the solver. Yeah. Okay, so the synchronization as defined in the paper is any instruction or operation that enforces the happen before relationship across the threads. And it should take one of these forms, a read or write from a heap variable, an invocation or entry point to an API or method, or the exit of an API or method. So these are the kind of things that the observer will pick up during the execution of the program. And so this is where the crux of the paper is at. So the properties is that the heap read cannot be a release synchronization, and the heap write cannot be a acquire synchronization. And yeah, so a method's exit can be a release synchronization, and the method's invocation can be an acquire synchronization, but it can never be the other way around.
Please explain a bit about those properties. The heap read cannot be a release synchronization.
Right. Okay. So let me.
Yeah. So here, I think if you now that you kind of understand the papers, you spend some time to understand that. But for the other students, you may spend a few time to understand what is a release synchronization and what is acquire synchronization. It's better to provide explanation like that, so that people can understand.
Right. Okay. So I can't really find the exact words, but I'll just like say my own interpretation. Right. So basically, the read cannot be a release synchronization because it does not. No, I think I should find the exact phrasing. So sorry, hold on for a while.
So maybe I have to explain to save time. So overall, in concurrent systems, we somehow will have some features like lock. So the lock is here. So sometimes we have sometimes if we have multiple threads waiting, so giving this a piece of code is called a critical session. Let me call it C. So why we call it a critical session is because, so suppose we have multiple process or multiple threads to visiting this portion of code. Only one thread can execute this piece of code. That means once the operation system or the compiler find that when some threads is executing this piece of code, and other thread have to block outside, waiting for, suppose let's take A, B, C. When A is enter these critical sections, B and C have to wait until A finish. So in this case, the something here is called a lock. That means A have to acquire the lock so that the other threads has to acquire the lock so that it can executing certain part of code. And after the code has been finished, after A has been also one thread has finished the execution of those critical sections, A will have to release such a lock so that B and C will compete to acquire the lock so that they can either of them can execute this critical section. So acquire synchronizations are more like A, B, C are trying to acquire the lock, and the release means that when some threads is executing these critical sections, they have to release the lock so that it can let other threads to compete and acquire the lock. So that is the overall background for the release and require. Have I made myself clear? Hello? Hello, Yuchen.
Oh, yes. Yeah, so that's for the release and acquire part. So I was searching for explanation on why the read cannot be a release. Right, so which is because a read operation cannot change the system state. So it cannot like notify when you cannot notify other threads to try to enter the critical region. Yeah, so that's the reason provided in the paper. And similarly for read, sorry, for a write operation, it does not perceive what is going on in the system, so it cannot acquire.
So maybe I have some complementary explanations. So if A would like to acquire a lock, it have to check some variable, right? It have to check because let me raise Java for example. I'm not now whether you are familiar with Java concurrency. So if it is in Java, suppose the thread A will try to acquire lock. It have to conduct an operation of read. That means that I have to check whether this critical sections has been under execution by some other threads. So that means if it is going to have acquire synchronization, it has to be a read instead of write. And similarly, if A had finished the execution of certain critical sections, it have to set the system state. So it has to be a write operation instead of read. Okay, so have I made it myself clear?
Yeah.
Okay.
Yeah. Okay. So it's similar for the methods also. Yeah. I think I'll move on because this. Yeah. So the properties here is it's kind of like the hard constraints that will be passed into the solver later on, and so afterwards there's properties and there are hypotheses, right? So the hypotheses are sort of like soft constraints that they.
Oh, by the way, Yuchen, before you reading the paper, are you familiar or now about Java concurrency?
Sorry?
Before you reading this paper, did you know about Java concurrency?
Yes, a little bit.
And by the way, Darren, are you familiar with Java concurrency?
Not really. The only thing I did was something related to func join pool a few years ago, maybe.
Okay, so have you selected the course of 3211?
No.
Okay, that is fine. Okay, you can keep going on. So in this case, when you are talking about the research work, maybe you can just also mention a little bit about the basics, so that people can understand.
Okay, sure. Okay, so the hypothesis. Okay, so basically they came up with a few. I guess you can think of it as heuristics as to determine when the release and when the acquire locks happen. Actually, I should show you this picture. I'm not sure if I added.
So maybe yeah. Maybe I could do more specified problem statement. The problem is that when we have a source code, we have a piece of code, but we have the whole project, and we would like to now because giving the code is have a lot of concurrency mechanism. So this paper, the goal of this paper is going to automatically identify which operation are used to operation means instructions or program statement, and which of them are used to synchronize the thread synchronization. So the paper is called the inference of the synchronization operation. So that is the goal of this work.
Yeah. So for this example here, if we have two events like A and B, right? And then we know that A happened before B. So there must be some window between these two events such that there was a release, there was a release and there was an acquire. Yeah, there's a release operation and acquire operation. And so we have all these events within the window, and the tool is supposed to infer for us exactly which event is the synchronizations happening. Yeah. So what this mostly protected hypothesis means is just that if you're trying to access the same variable between all the threads, then it should be synchronized. And okay, so another one is like synchronizations are rare, so it should only constitute a small portion of all the operations. Yeah, I think it's more clear afterwards. So there will be some. I think I'll talk about it in more detail later. Yeah. So acquisition time mostly varies. Yeah. Okay. So this is where the perturbation also comes in, because let's say that if you are waiting for some resource to be free, then you might have to wait very long. And so if the execution of a method takes roughly the same amount of time, then it is unlikely to be an acquire.
Let me
so similarly,
let me put it. Let me redigest it. So let me. Okay, I got it. Okay, so that makes sense. So that means the time spent to acquire a lock have to be a little bit random, a little bit chaotic.
Yep. So they also use this fact to write the perturbation mechanism. So let's say that you have this series of operations here, and then we introduce this delay, right? And we realized that even though this delay happened, the execution of B was not really affected. Then we know that okay, R is probably not the release synchronization. And whereas if we inject the delay before this window, before this event R, and then this delay affected B, so we know that there's a high chance that R, or maybe what happens behind R, is going to be the synchronization.
See about it. So you're talking about release synchronization, right?
Yeah, this is just for the release. Yeah. So
so how does this delay play a role there? So would you please be more specific? Maybe I didn't get that. Would you please show your paper again, or the diagram again? Yeah.
What's the question again?
The question is that why the delay can play a role here?
Why the delay? Okay, so it's also partially because of the mostly protected hypothesis, right? So let's say that these two events are accessing some conflict. They're accessing a shared variable. So if A acquires the lock first, and then it does the thing, and it needs to release before B can come in to also access the variable. And if the delay is happening before the release, then it means that B have to wait longer. So
delay happens before the release.
Yeah.
Yeah, B have to wait for longer. Yes.
Yeah. So when we see that B needed to wait longer, and yeah, so it's affected by the delay, then we know that there's a good chance that there's a pair of release and acquire synchronizations happening inside.
Yeah, you're right. Okay, so this is very clear. So that means, okay. So for thread A, so when say we'll have another, so your point is that if a delay happens after A, but the B is not affected, so the B is executed as usual. Okay, the point is there. Your point is there. Okay.
Yeah. So R is probably not the release synchronization. Yeah. Yeah. Okay. So another thing is the mostly paired. So if you're going to read the same variable, then it is, if one of the variables is used for the acquire synchronization, then the corresponding release synchronization is very likely to be the right of that same variable. Yeah. Okay, so it's just now, like I said, why written as C?
Okay. So Darren have a question. Which one? Let me go back.
Yep. So the question was why variables is written like this, right? It actually is just a random example given in the paper. So V is supposed to be a variable of class C. yeah, that was it.
Let me go through the last sentence. Synchronization. Okay.
Okay. Yep. So just now the perturbation that I was talking about. So basically, after a run through of the program, the observer will like generate this list of windows and events, right? And then after running through the solver, we have a probability for each event to be a synchronization. And so the perturber will just inject a delay around those top synchronization candidates. Yeah. So the reaction towards this delay will either strongly support or dispute the existing inference results. And from testing, it showed that most of the synchronizations come out after 1 to 3 runs. Okay. Yes. So this is the picture that I was trying to show. Right. So the observer, basically what it does is that it captures all the read and write operations and the access to the heap variables and the entry and exit of methods. So from each pair, we generate a list of the windows, right? So we have this set of events happening here. And they also do a bit of filtering. So for like a given pair, let's say like of conflicting resources, right?
So
If
here
the-
appear. So may I be more specific? Appear what? Appear of thread.
Oh, it's a pair of like the access, like
Appear
like,
of a read or write access or.
yeah. It can be any pair, to be honest. Like it can be the entry and exit of methods also. It can be read and write operations.
Okay.
Yeah, so all of these, like they will pair them up and then they'll create this window. And if so one of the parameters that they use to filter out is also because like if two events are very far apart during the like execution timeline, they will ignore it. Yeah, so I didn't put it in the slides, but so their variable is like 1 second. So between each pair, if it's more than 1 second, then they will ignore this for the to be piped into the
So
solver.
you're only looking to the instructions executed within a window, right? A period window.
Yeah. So they
And then
limit the maximum size.
Yeah, the point is that so if the period of operations that happens within a period, so it's likely that one of them is supposed to be, and also these operations are coming from a different thread. And it means that there's supposed to be a synchronization operation between them.
Yep. Okay. Right. So this is just a formulation of the constraints into a mathematical problem that they later pipe into a set solver to solve. So yeah, so F is for the field, and then the release of the probability that it's a release synchronization, given that it's a reading of this field, is 0. And if it's a writing to the field, the probability of it being an acquire synchronization is also 0. And yeah, so you read this line similarly. And there's a lot of others for each hypothesis, but I skipped most of them. So I think you can just see from the components. This one would be the hypothesis that they are mostly paired. And then
Mostly what? Mostly what?
Mostly paired. So it's
paired. Oh, okay, so paired.
Yeah, so it's the first. No, sorry, mostly protected. Yeah, it's the first one. It's mostly protected. Yeah, so mostly paired is another one.
So will you please mostly, I didn't understand what is mostly paired and what is mostly protected. We need to be very clear on this part.
Okay. So mostly protected is that the conflicting accesses in the mature software should be synchronized. Let me find the exact words.
Yeah, I suggest you need to prepare those definitions instead of search from the paper.
Right, because it's also somewhat arbitrary, I feel. It's like, okay, so given the strong semantic connection, the author define, oh, this is paired, mostly protected is here. So yeah, so for access to some variable a and like the same variable, and then those are conflicting accesses, right? So between them there should be synchronization.
How do you define conflicting accesses?
Conflicting accesses. I believe it's when you access the same variable. So
Or maybe
a
write.
read or read or
maybe
write operation.
I think read or write will be conflicted. I think maybe to write will be conflicted.
Mm,
And how do you define? Can you raise the example for conflicting accesses?
I don't think they did. Like my interpretation was just that when you access the same variable, then yeah. I think I might need to like look into it more because they didn't offer any more.
Mostly protected means that the majority of the conflicting accesses usually read and write may be a conflict access because you usually have to wait for one thread to write because it cannot be read and write happen at the same time. The problem is that what if the read and write happen simultaneously? What if the read operation will read an obsolete value? Have I made myself understood? So the point is that suppose we have thread T1 and thread T2, and the thread T1 is going to read a variable A, and the thread T2 is going to write a variable A, right? Suppose there's a variable A here, and if T1 read this one, T1 is read one, and T2 is write this one, right? So in this case, if T1 and T2 happen simultaneously, the semantics will be different. It is that if T1, if write happens first and read happens second, then the value supposed to write is going to increase the value by 1. So the variable A we read is A plus 1. And in contrast, if the read happens first and the write happens second, so we will get the value we read is A. So it makes the concurrent system unstable. So we will consider read and write as a conflicting access. So by this means, we have to make sure. So once we find a shared variable is used by multiple threads, usually we have to using lock to protect them. So here's maybe here's the idea of the mostly protected. Okay. So would you please go with the most paired? So would you please move on this part? Given a strong connection between the release and the corresponding acquire, they are often defined in the period and the cluster way in a very maintained software. Here's the read of a variable B is used for acquire synchronization, and the corresponding release is very likely to write. Okay. Well, the point is that the release and require we're usually using the same variable instead of the other variable. Okay, that is the heuristics. Okay, let's keep going. We'll go back to that will be kind of straightforward.
I guess
Okay.
I'm a bit, I got the two mixed up because is there a case where your read and acquire is on different variables? Sorry, your release and acquire. Is
For
there
me,
like a
I haven't
exception?
experienced. For me, I haven't experienced that. But since the paper mentioned that, they must observe some cases there.
Okay. Right.
Okay, now let's look at the objective function.
Right. So the objective function is made up of all the different hypotheses, and each of them, like each var, this rare and stuff, is also another function, which I didn't add in, but we can go through if everyone's interested. So this
And so what do we need to know is about what is this object function for, and why is optimization problem?
Why there's an optimization problem? Okay, so so essentially we are trying to assign probabilities to all the events that we have observed, right? Okay, so but these events also need to satisfy the constraints, which is partly this and also partly from all the objects, partly from all the hypotheses. Yeah, so that's where the objective function comes from. So it's a representation of that constraint satisfaction problem. And then we pass this function.
So release W, what does release W mean? That it is a variable used as the probability of release. And what does that mean?
So that one is
I think this part should be very, very clear.
Okay. So this one is part of the mostly protected hypothesis, and is defined like for each event, the probability that it is a release acquisition is summed up, and then we take 1 minus that, and the release of that whole window is supposed to be as low as possible. Yeah, so
what does W mean? W is a set, right?
W, yeah, is the
window.
window.
W is a window. So release of the window is equal to the why? I didn't get the point. So you can see, suppose a window is a release, right? So why it will be a negative relationship between the release probability of window and the release probability of this action?
Sorry, what relationship?
Why there's a negative correlation? By right, the window, the more likely a window has, the more likely the window has a release action, the more likely the window is a release rate, right? So what does it mean?
It just means that one of them must be a synchronization within that window, because
let me assume AI release is equal to 1, right?
Yeah.
So it means that the release, the probability of release W is 0. And what does this 0 mean?
Oh no, this one is just the function. So the probability is assigned to the action, and then this one is just the part of the objective function to be minimized.
Okay, so what does the release W mean?
What does it mean?
Yeah.
It's just,
It means the likelihood to not be a release function.
if it's close to 0 means that the assignment is done.
Assignment is done. So would it be more specific? Acquire. So what does this the semantics of the release W mean? Okay, if it is the maybe may I ask a question? So can you answer these questions or not? If not, we can just skip this point and keep going on.
I don't really know. I think it's just a way to encapsulate the fact that there must be a high probability in one of the elements in W.
Yeah, I understand. So
Yeah.
suppose I just raised a question. So there's many AI there. Suppose one of AI release is equal to 1 and the release W is equal to 0. So my question is that why there's a negative? Because you can see what does this negative mean? And also acquires do the same, right? So given the window, suppose there's many acquiring operation inside the window and the acquired window. So the score of the acquiring such a window or the score of the window you have acquiring it becomes smaller. So what's the point? Why is there? Why there's such a expression?
The acquiring window became smaller.
This it's going to minimize.
I don't really know. Yeah, it's just to minimize this. The window itself is still the set that they didn't really change.
And okay, the minimize the W is going to maximize AI. So what is a variable here? So may I ask what is the variable? W is not a variable, right?
No, I don't think the window changes.
Yeah, so what is the variable in this formula? The AI release.
Yeah, correct. Each action. So they will assign a probability to each variable there, and then this variable needs to minimize this function along with a lot of others.
So that means that at least apply to the point. Okay, it means that given a window, you must have a release and a required.
Yeah.
Okay, let's maybe we. Okay, so can you go back to the objective functions? So this is all the hypothesis. Okay.
Yes. Yeah. So all of these are the hypotheses, and then what I'm trying to get at is that there is a much larger weight on the mostly protected hypothesis than the rest. And then you can see that because they wrap it in the lambda, and their default value for lambda is 0.2. So this is like a lot
so
more
how
important.
do they do the search, or how do they? So this is objective function, right? So what is the constraints? Because this is objective function. What is constraints?
The constraint is one of them is this, and then the other one is like all of these law. So this is a constraint, and this one must be minimized. That's one. And they also have something called like there's something called a single purpose. So like a specific one can either be release or acquire, and not both. Yeah.
Keep going on. Let's keep going on.
Okay. Yeah. So basically, it's just that this is the most important hypothesis. Yeah.
Okay.
Yeah. So they mentioned that they will add new variables and corresponding constraints if new synchronizations candidates show up, but I'm not exactly sure how they do it. I think it's because like for each input they run multiple times, so perhaps it's from multiple inputs that they get new variables and candidates. Yeah, so each newly observed release window, they will add in new function terms and they will update the existing function terms across the runs. So like just now I mentioned, every run the perturber will inject a 100 millisecond delay right before the dynamic instance of what is considered a release synchronization. Right, so there can be a case
Okay, maybe
where,
I can, maybe let me finish, I will give my comments.
okay.
Okay, keep going on. Let me finish with the next race and I will give some comments.
Oh, okay. Right, so data race is what happens when you access a variable without the synchronization. And this is observed by SherLock when there are two conflicting accesses and every operation in the window is guaranteed to not be a synchronization.
A concurrent execution of two conflict access with every option in the window guaranteed not to be a synchronization. Okay.
So SherLock will just remember and it will remove the mostly protected penalty term. So mostly protected is this one. So this will just be set to 0. So they won't care about this term. And then, yeah.
Okay, so maybe I give my comments here. So their approach is basically heuristics based. So I think that the key insight is that they are doing some additional delay. So that is their novelty here. So we'll go back to the previous slide. The previous one, and the previous one. Yeah, this one. So I think all these papers, because this paper is published in a very top tier conference called ASPLOS. It is a system conference paper. And in these papers, we sometimes when we write a paper, we need to formalize the idea. But anyway, the gut feelings or the rationale is quite simple. The idea is that suppose A and B supposed to be synchronized. That means A has to happen before B. So assuming A happens before B, there must be some operations between A and B, like A1 to A3 and B1 to B3, supposed to synchronization operations. Suppose there's an operation there, a delay happens after A, have to affect B. Otherwise, there's no synchronizations. A and B, the delay of A does not matter, right? Does not matter. So we can see there's such a change. Once we got such a change, then the follow-up work is try to formalize such idea. So they will define some heuristics, and each heuristics will be encoded as a constraint. So they are going to solve the equations. Maybe from the implementation level, there's no need to be a solver there. Maybe some heuristic-based idea can still get some precision result here. Okay, please go on.
Okay. Right. So other than that, it's just the results really, and I didn't really like look super close into it, but I think the interesting things from their analysis is that there are some missed synchronizations due to the single row assumption. So one example is that in this C# program that they tested, there was use of upgrade to write lock, which will release a read lock and then acquire a write lock, all within one API call. And this caused the SherLock to miss one synchronization and then also report 15 false data race reports.
So that means lock usually happens inside in a very fundamental low-level operations, right? Upgrade to write lock. Okay.
Yeah. So the improvements that they listed would be to try to make a single row assumption, this assumption to be a soft constraint rather than a hard constraint. Yeah. And then another thing that another thing that SherLock is not able to do is that it is not able to control when the garbage collection happens. And yeah, so that would affect some of the accuracy.
Will you please more on how the garbage collection can influence this accuracy?
Right, because of the way the perturbation works. So it might happen that there's some like, I believe they call it like finalizer or something to be run at the end of the lifetime of an object. So that finalizer might be require synchronization, but the problem with it is that finalizers usually run only when garbage collection happens, and because SherLock cannot control when the garbage collection happens, it is not able to detect that well.
Okay, I see. Okay, keep going on. So I think we can just finish this presentation within 5 to 10 minutes.
Yeah.
So let's look into how they do the experiment.
Really done.
You're done. You are already done.
Then
okay.
Yeah. Experiments. I didn't really.
So maybe you are the first
exactly
time.
How they do
Yeah. So maybe you are the first time to prepare the presentations. I understand the presentation preparations has overhead, especially for undergrad students, because when you are reading the papers, you are trying to acquire the basic knowledge, especially if you're not that familiar with concurrency. And also this assistant paper, and the authors are all the very famous professors and PhDs and very promising PhDs. And since you are undergrad students, you still have a lot to learn. But overall, I suggest that given this is a research positions and we have a research group, and we suggest that you digest sentence by sentence. I understand at the very beginning, the process is kind of daunting and effort consuming and time consuming. I think but the benefits pay off. And once you get yourself adapted to such a process, you will read the literature very fast. And also each paper is usually the paper published in the top tier conference are well structured. So the well structured means that the logical chain is very, very clear. Now, even sometimes you do not understand one section, maybe it's totally fine because such sections usually the self-contained or self-encapsulated. So for example, let me raise example for this paper. SherLock may have some heuristics to identify the probability of each operation to be acquire or release operation, right? So they have a lot of heuristics. Maybe you are confused with one of the heuristics, but it's fine. You will know that there are a lot of heuristics, heuristic A to B to C, and each heuristics will translate into constraints. Maybe you do not understand one constraints, but anyway, given their structures, you can easily infer the overall idea. So it will not impair your understanding of the whole paper. Yeah, so that's my first suggestion to you is that when you read the research papers, I encourage you to digest, to grant the details. So that will definitely help. And also our work is going to proceed into the concurrency analysis. And how do we tracing the concurrency programs, and how do we identify improved instrumentation of the concurrencies? That is all very relevant. And my third suggestion to you is that in the future, when you do the presentations, experiment is very, very important. It is because we are also the authors to publish. We will one day we will always also be the author to publish. So how to evaluate their approach is a very, very important aspects. And for you, maybe for a lot of beginners, they care about the approach a lot. But usually the senior researchers care about experiment a lot, because it's usually decided whether this paper can be accepted. So also I suggest that you revisit the experiment and maybe prepare your slides and share the group again.
Okay.
Okay, thanks. And after you recap the slides, and please share the slides in your group.
Sure.
Okay, thanks, Yuchen. So it's good for as a beginner for the first time to prepare the paper presentations. Next one, how about Rofan? Oh, sorry, Xianglin. Can you please give your presentation?
Okay. So the paper I'm going to present today is called Interactive Visualization for Debugging Reinforcement Learning. It was submitted to ICLR 2021, but it got rejected.
Okay.
Because I saw the open review and
okay, it gets rejected.
Yeah, I get rejected.
Do you think there's any insights given from this paper?
Yeah, of course. So the first author, he's now a researcher in a startup company in United States, but previously he was a master student in the in CMU. And I think this paper should be his master thesis. And the other two authors, one is a PhD in CMU, and the other one is a research professor. The background of this paper, the visualization tool to understand the success and failure of deep neural network in supervised learning area has been proposed by many researchers. We know, for example, like computational graph, activation maps, and the line plot of loss and accuracy, for example, and also our tool. But the problem is this paper specifically looking to the reinforcement learning research area, and I think the reinforcement learning is more interactive and requires more feedback loops from users. And all the existing tool fails to provide such interaction between users and visualization system. So their vision for the visualization system, which I think is benefit for our work as well, is that they think the visualization system needs to consist of two components. One is representation. So representation means how data is mapped into a representation and then rendered. And for the interaction means the dialogue between the user and the system as the users explore the data to find insight. And they also mentioned another researchers that his idea on the to evaluate the visualization system contains three dimensions. One is descriptive power, which means the ability to describe a significant range of existing interface. And for the evaluative power, it means the power or the ability to help evaluate some alternatives. And the generative power means the ability to create new designs. So I think
so these two powers was a little bit abstracted. So descriptive means that how well it can be,
how well the representation can be, I think.
How well the representation can be to convey the information. And can you be more specific on the
evaluative?
Evaluative. So you mean the two?
From my understanding, it should be like users may ask question like, what if something happened, or what if
so literally evaluative is more like I'm not sure whether I'm correct, so just correct me if I'm wrong. Evaluative is more like once we just talk about it from my point of view. So when we do the visualization, so for our work, we usually have to project the high dimensional point into low dimensional point. Right? So it means that what we see in low dimensional space may not be accurate if we look into if we think about it, high dimensional vectors. So sometimes in your system we will have a measurement like the confidence, the molecular evaluation confidence. So I'm not sure whether it is relevant.
I think it's not, because the 3 dimensions to evaluate the it should be, for example, a model might have different hyperparameters. Then your visualization system should be able to evaluate how good of each the hyperparameters, not to evaluate for example.
But how good is the hyperparameters, right? So if I understand correctly, you mean that our system should be evaluated how good of the hyperparameters used for visualization.
Not for visualization, but for the subject model.
Okay. So maybe So your point is that the way to evaluate
the original model.
So what do you use the VIS system?
Oh, visualization system. So I didn't visualization system.
Okay, it's a visualization system. If it is a visualization system, isn't that power is going to evaluate
the original the model that we try to visualize the subject model. So that it needs to have this visualization system needs to have the power to describe the original the subject model, to evaluate the subject model, and maybe generate some new idea or some new designs to improve the subject model.
Okay.
Yeah.
So that'll be okay. So anyway, so these two terms, it's good word, but not sure. Let's keep going on. So I haven't got much insight because this is what we see. Just as you explained, right? So may somehow faithfully reflect what it is, faithfully reflect the subject models, and evaluate the capability or accuracy of the models, and to inspire new ideas. So that's a good word, yeah. But we need to look into concrete points to support, or concrete evidence to support those ideas. Let's keep going
on. So they propose a interactive visualization system. First they said it has the descriptive power to visualize the reinforcement learning model, and it also tries to answer deeper questions. For example, what sequence of dynamic cause the resulting agent behavior, or how does the state distribution change as training during the training. So they are all specific about the reinforcement learning area. And a little preliminaries. I'm not so familiar with reinforcement learning, but I think this slide tries to give us a high-level idea on what is reinforcement learning, and there should be enough to interpret it later content.
Okay.
Yeah. So the reinforcement learning contains an agent and environment. So first, an agent would interact with environment, for example, at time step t, and then it should have, and it should first decide, the behavior of agent should first be decided by one policy pi, and then it will map the states to action, and then it would receive a reward based on the state and action by the environment. And for the environment, it should have a initial state P0 and one transition function to, based on one state and action, it would transit this state to another state t+1. And you would also have this reward function to give a value to evaluate how good this action is.
So the reward is giving on action instead of state, right?
Based on state and action. So it has two input.
And is those state explicit?
State. What do
the state means, for example, if I'm saying that I just raised the application for reinforcement learning. One simplest example is let a robot to get across a maze. Get across a maze. So in that case, the position is the state of that robot, and in that case, a robot is an agent, right? And the state is the positions. Is positions in the maze. And its actions maybe go up, go down, go left, and go right, right? So it will, at the very beginning, you will have policies like random policy, for example, and it will map, just want to say map a state and actions. But anyway, it will finally get a reward. So given the reward, it will, but there's always a way to calculate the reward. So the question is about the transition function. Okay, so the transition function is just giving a state, given the current position S, and we would like to take action, like go up and go down. So we will reach another position S prime, and finally we will have the reward. Okay, please keep going on as the replay buffer.
And replay buffer, I think it's a technique adopted to speed up the reinforcement learning, because each time for the reinforcement learning, you would have action, state, and then interact with environment, and then again. So this process should be quite slow. And if they store the agent's experience, which is the action, state, reward, and then the next state. So this should be one experience, and then they store some experience, and later they can replay this experiment from buffer, and it should somehow speed up the
so
process.
maybe I have a small question. Maybe you can just Google it later. So how do we define or update the reward? So usually
How?
So assuming that at this position, because AlphaGo is just using reinforcement learning. So once we start a position or state ST, right? And we take an action AT, and finally it achieve our goal. For example, if the robot get out of the maze, so we will have a reward. But this process may take a very long path, and finally get a reward. And how do they update this? The reward of action. So here we action go right, go down, etc. And how?
Oh, you mean each step?
Yeah, each step. So more like it's more like a process. So for example, the success is formed or contributed by a sequence of actions.
Mm,
So I know that each actions contribute somehow, and each action is supposed to get some reward. And how this reward can be distributed among a subset of actions.
I think it's not precise from my understanding. For example, in the maze case, if the robot eventually got to the center of the maze, then, for example, the reward can be 1,000 or a high value. And then it might give the agent a time, for example, time penalty. So if it
That makes sense. So that means
if it step I don't know, for example, if the agent make a move and then the time penalty might for example minus 0.1, but the ultimate goal is 1,000, so eventually it would try to reach the goal.
okay, maybe we can skip these ones.
Yeah.
We can keep going on. Things done.
And then it's the design. So they have 4 core elements. One is image buffer. It should be quite easy to understand. They would show the image or the environment in one viewport. And then the second one is line plots, which is to show the metric.
Okay, you're getting the point. So which one is image buffer?
Which one?
Which one is image buffer?
Image.
So,
The first one.
The first one is the
image.
The black one.
Oh yeah. Can I comment?
Yeah. So you can just
the upper left one is image buffer.
Okay.
And then
why
bottom left one.
What's the difference between the image buffer and the replay buffer?
Replay buffer.
Yeah.
Replay. So here we have 4 core elements, right? The line plots, scatter plots, histograms, and image buffer. This is like
orthogonal.
Oh, not orthogonal.
Or independent, or
they are the smallest element. For the replay buffer, they combine some core elements together to form a replay buffer. But this screenshot is from later slides.
Okay.
But I just tried to show you the scatter plot and histogram.
So I think my question hasn't been answered. What is image buffer?
Image buffer. It's just a view to show the image.
And how to read that view?
How to read?
Yeah.
Later in their design, for example, in the scatter plots, if you click on one point, which represent, for example, an action or a state, and then the image buffer can show the image correspond to that point you click.
And maybe you can give more examples.
Yeah.
Can you give more examples? So I'm still confused to see what's the value or what's the function of image buffer. I think replay buffer is kind of easy to understand because replay buffer means that each of state, what is the value of action, what is the reward to take each action, right? But I'm also a little bit confused on why the scatter point can help to show such a case.
In their paper, they said that to see an image is better for human understanding.
Yeah, I'm just very curious on how are they going to show the process of reinforcement learning and what insight can they bring us?
Maybe we can keep going on and see. So first, they separated their views into two parts. One is temporal views and the other one is spatial views. And for the temporal views, it means to view the data streams such as actions, rewards, and images as a sequence of time. So here is one example to show the state viewpoint. In this example, it's a inverted pendulum task. So basically, it tries to make sure the stick never go down, right? And then they define the state as cosine theta, sine theta, and theta. Theta is what is the angle between the vertical line and the stick. And they use three line plots to show the state. The first one is cosine theta, the second one is sine theta, and the last one is theta. And on the right, they also have an image buffer. So if you click on one point, for example, and it should be able to show the state image.
So the first question is that where is the point and which point should I click? And they're still quite confused about what does the image mean. Does the image mean the stick or?
Sorry. So this image is from
So this
they didn't show the inverted pendulum task image, but this is the idea.
And
so
also
to put.
Okay, so this is a temporal view to showing.
So x-axis is the time step, and y should be the value, the cosine theta, sine theta, and theta.
And what if there's the one-sided variables to represent the state?
So they say for high-dimensional state data, they would display individual states. So I assume for each dimension, they should have a
so they have one-sided plot, line plot for such a case. And the image buffer. So here, I think it's easier for us to think about it. But what if you can think about it AlphaGo? So what is supposed to be shown in image buffer? You know the games of Go, right? The games of Go, and
so maybe
each stage is supposed to be a positions or a positions to put a stone on the board. So how could that be shown in image buffer?
I guess it should show the
and also what is the image buffer, and what since it's a graph, right? So in this case, and it also shows the trajectory, right? Or the trajectory. So there's a brown line in the gray background. And what does this trajectory mean? Okay, if you don't know,
I'm not sure.
Keep going.
And then for the action viewport, let's give an example. So this is the Pong environment. The white dot. So I think on the left is the computer, and on right the green one should be controlled by human. And you should try to
get the bat back, right?
Get the ball back. And if you get the white ball back, you should get 1 point. If you miss it, you got 0, and the computer gets 1 point. And they use a histogram to show. I think it shows the position of the action. And again, the x-axis
and
is time.
and what is the state? What is
State.
what is state variable shown in your picture?
State.
Yeah, what is a state variable? In your line, in your line chart.
This is action.
Action.
Yeah, because now we are talking about the action viewport.
Okay, action viewpoint. And how to read this chart? And what is the x and y axis mean?
X should be the time steps.
And y?
Y should be the action. I suppose it's the position. Because the image is blurred, even in their paper. So still, I cannot read the y-axis.
Can you go back to the previous slide?
Mm.
And the previous one. And previous one. So it's still a line plot, right? Still a line plot.
It's a histogram.
Histogram.
Yeah.
So, and for histogram, how could it be axis to be time? Yeah, I just feel there's something wrong here.
Let me see. Base. If you look very carefully, then it says time steps in the x-axis.
But it looks like a line chart, right? So you can go
to
the previous one.
Yeah.
So
and
the previous one, and it looks like the previous one. And there's still a line steps, right? Time steps. Right, there's still time steps. So it means that it is not a histogram.
Yeah, then maybe I don't think their paper is well written, but
So may I ask, what's the main reason to reject this paper?
They don't have much experience. In the experiment.
Okay, please keep going.
Yeah. And for the reward viewport, line plot should be enough to visualize the reward. Yeah, and for the spatial views, you try to visualize the data stream as a spatial distribution of events. Here, the replay buffer, remember that each experience is consists of 4 parts: the action, state, reward, and the next action. So it has 4 dimensions. In order to plot those points in 2 dimensions, they use the t-SNE to reduce dimension. And
the point is the action is a numerative variable. Right? And how do you I think there's something wrong there. How could be they using t-SNE to reduce the dimension? It's not possible, right? So it means that focusing on state 1 and state 2. And also focusing for an action 1, action 2. There's no continuous relations in the action. Right? Only the reward is possible to conduct dimension reductions. And all the rest, the state, the variable state, suppose the state 1, state 2. How could they? And do you think state 1 is smaller than state 2?
Then I think, for example, in the inverted pendulum task, the state should be, for example, the cosine, sine, and theta. So maybe it has 3 dimensions, and then the action might be the distance of that car moved. Then it's 1 dimension, and the reward is 1 dimension. And then again for the state, it's
Yeah,
three
but
dimension,
but
and
but
then
if, but if for the maze, the action means you need to go up and down and left and right. And how could so then it's all 0 or 1, right? It's all almost 0 and 1. And for those states, it's of course some of the dimension the state could be continuous, but the dimension anyway the dimension it's actually good. So anyway, they try to use T-SNE to project into two-dimensional space. And what does that mean?
So this
How to read these dimensions?
the dimension
How to read these?
has no meanings, but they try to show, for example, there's one cluster and on the bottom there's another clusters, so they should behave similar.
Very little insight, at least for me. I can extract very little information from those visualizations.
So that's one of the reasons why it got rejected.
That's my fault too.
Because lots of reviewers says that even though they provide this interesting idea, but they didn't answer the question on how this visualization can help to debug the reinforcement learning.
Okay, keep going on.
And then for the distribution viewport, it complements the replay buffer viewport by allowing the users to choose to customize the clusters and see their distribution. So like they can circle.
I think this also brings very little insights to count the number of X means action. Okay.
And then the tensor comparison viewport is quite simple. You just click on those 3 points and see their original tensor and compare yourself. Yeah. And then there's trajectory viewport. The x-axis is time, and y should be. The point is, I'm not so familiar with trajectory, so I just skip this part. But the point here is they use this histogram to show the trajectory.
There's also the image buffer, right? So the right one is the image buffer. And what does it mean? And what application is used?
What? Sorry?
What does it mean for those image buffer?
So again, you can click on some points and it can show you the state.
Okay, let's skip this. So
and they provide a example of workflow on how to debug the reinforcement learning using their tool. So first, it's a high-level idea. First, they should load a policy from checkpoint into their tool, and then the tool could evaluate the policy through a specific number of rollouts. So which means the viewports we saw earlier, and then all data is visualized by the user through all the viewports, and users can make guided changes and further use those guided changes to retrain the reinforcement learning model. Yeah, so that's their idea, and yeah, that's all.
okay, so maybe this paper.
Yeah, and
the reviewer have no choice to reject this paper, I think. The issue is not very clear how these two can help. But anyway, the overall idea will be it's still an IDE. So if you are using PyCharm, there's a lot of view there. So there's a view of debugging view, there's a view of editors, there's a view of the project. view, their view of file structure. So once we have other views, we just like a pilot driving a plane or driving a car. So with this metrics monitoring, we can make those decisions. So anyway, so what we have from the training process, for now they are also learning the ring. They are also trying to investigate how the reinforcement learning can form some policy, right? So, and once giving a policy, how the reward system can be learned, and why would they were form such a reward if we make such actions. So they're trying to answer these questions, but of course they didn't address the problems, and they only throw away some very preliminary visualizing solutions. But anyway, so once the idea is more like tracing, from my point of view, it's more like tracing. When during the training process, there's a lot of events, there's a lot of the key events happens, and we collect the trace. And the trace itself is just data. We're going to extract the information from the data and extract the knowledge from the information, and further to decide, to make decisions based on the information. So the overall process still the same, but there's still a large way to go through it. Okay.
Yeah, the reviewer suggests they should conduct a user study to show what this tool can do and how it can help to debug. So, and they only
and also once we develop new tools, there's also a learning curve for the new programmers or data scientists. Right? Because once the new tools, even if you're using deep visual insight, when they see the boundary, they have to learn a bit about how to use it. Okay, but anyway, so next time when I choose the papers, I'll be more careful in case choosing a revision papers. So to bring us the rationale is good, but it didn't bring us less insight for an idea to digest. Yeah. Okay. And okay, so thanks Yuchen and thanks Xianglin for today's presentations. And I think we have less questions than the last time. But anyway, for Yuchen, we suggested to learn more about the concurrent systems, learn more about the detailed techniques such as implementations, and after this, since it's a weekend, and we're supposed to synchronize it, Yuchen, when we're available for us to synchronize the tasks we have, for example, the data management systems and the trace recording task.
The original time was tomorrow, like 3, right?
Yeah, we will have a meeting tomorrow, 3 p.m.
Is it possible to push that back a bit?
Okay, so when will we finish that? So 6 or 7?
Oh yeah, that'd be better. Maybe 7.
Okay, let's better 7. And for Xianglin, maybe you can finish all the to-dos in synchronized form. And when job is done, we will finish the. I will try the tool again. Okay, thanks all. Let's go there. Bye.